What makes airplanes fly, car brakes stop, and massive hydraulic machines lift tons of weight? It is pressure. It's one of the most important concepts in engineering and one of the most misunderstood. A small mistake in measuring pressure can lead to system failure, safety risks, or costly damage. So, pressure measurement matters. But pressure isn't just in industrial systems. It's in your tires, it's in your kitchen, it's in your lungs when you breathe. Pressure is everywhere. In this video, you will quickly understand the difference between absolute, gauge, and atmospheric pressure, and how engineers measure them in real life. Let's simplify pressure once and for all. Let's start from the real zero of pressure, which is a perfect vacuum. Absolute pressure is measured from here. And this is atmospheric pressure, the pressure surrounding us every day. Now, when a pressure gauge reads zero, it's not zero pressure. It's zero relative to atmospheric pressure. Let's go with example to understand each one. If the gauge shows 50 kilopascal reading, the real pressure, which is the absolute pressure from vacuum, it is 151 kilopascal. In other words, in this case, atmospheric pressure 101 kilopascal plus gauge pressure 50 kilopascal equal to 151 kilopascal, and this 151 kilopascal is the absolute pressure. Gauge pressure can be negative. In this case, the absolute pressure is 101 kilopascal minus 20 kilopascal, and then equal to 81 kilopascal, and this 81 kilopascal is the absolute pressure. Put in your mind, absolute pressure can never be negative. However, negative gauge pressure, sometimes called vacuum. This graph summarizes the relation between the absolute, atmospheric, gauge, and vacuum pressure. Now we come to this question: how to measure pressure? To measure atmospheric pressure, we use a barometer. The first one was invented by Torricelli. It works by balancing atmospheric pressure against a column of mercury. However, nowadays the modern device named aneroid barometer is used. It doesn't use liquid, it uses a sealed metal chamber that expands and contracts with atmospheric pressure, but we can name it just barometer. To measure gauge pressure, engineers commonly use a Bourdon tube gauge. It measures pressure relative to atmospheric pressure. When it is gauge pressure, means pressure above atmospheric. If it's negative, below the atmospheric. In modern engineering systems, we often use electronic pressure sensors that convert pressure into electrical signals. For examples, used in automotive systems, it's used in HVAC system, used in industrial control systems. Then we can summarize the type of pressures and how they are measured and what is the reference point for each one. Here we can see atmospheric pressure used by barometer, reference point sea level, and the gauge pressure, it's measured by Bourdon gauge pressure, and the reference is the atmospheric, means the gauge pressure inside any equipment could be above atmospheric pressure or below the atmospheric pressure. When it is above, it's positive; below atmospheric, it is negative. And finally, absolute pressure, it's measured by absolute sensors, and the reference point is vacuum.